today's lecture, we are going to see the history of Java, where it was developed and how it was developed. And at the same time, we'll see Java milestones also, different versions of Java when they are actually released, and also some of the Java features. Do you know why Java has become a popular language? Because it has many good features. Like it is very simple to learn Java. So I think many of you know C and C++. So the syntax of Java is very similar to C and C++. So you can easily learn. It is very simple. And Java is object oriented. And at the same time, Java is platform independent. So once if you write a Java program and if you compile it, then you can run the Java program on any machine. So like that, there are many advantages of Java or many features of Java. So we are going to see all the features in this class.
Now let's see the history of Java and features of Java. Java was originally developed by James Gosling and his team at Sun Microsystems. It was the company where they first developed the Java language. It was in the early 1990s. It means 1991, 1992, like that. They started the project, and James Gosling and his team they developed Java. Then James Gosling and his team first named their project as Green Tag. They named it as Green Tag, and later they named it as Oak. But after much discussion, finally they gave a name, Java. Okay, then Java is a general purpose programming, object oriented programming language. What does it mean? General purpose programming means we can write any type of program by using Java. For example, if you want to add two numbers, which is a very simple program, you can write with Java. And at the same time, if you get the details from a database, such a complex project also you can write with Java. So Java is a general purpose programming language. We can write all types of programs with Java, and at the same time, Java is, now we know that Java is object oriented programming language. Everything is Java, everything is object in Java. Then Java was originally designed for consumer electronic devices and embedded network applications running on multiple platforms. It was not originally designed to solve the problems of writing programs for solving some mathematical equations, not like that, but it was originally designed for consumer electronic devices, like remote controls and some other electronic devices. To work with those devices, these people they developed Java. Then Oracle bought Sun Microsystems in the year 2010. In the year 2010, there is another company called Oracle Organization. That company took over Sun Microsystems. So actually, it was developed at Sun Microsystems. Now we can download the Java software from Oracle website. This is the version history of Java. Just now I told you that Java was, that project was started in the early 1990s. So they they released the first beta version in the year 1995. Then from then onwards, or from every year or for every 2 years, they released new versions. Do you know these are all versions of Java? These are all released month and year, right? These are all versions. Now for each version they have included some new features. So that's what we need to remember here. New features are being added every version. Now we are in Java SE 14. Now you can see Java SE 14. It was released in March 2020. Java SE 14. Then it will be released in Java SE 15 will be released in September 2020. Anyway, there are this is the version history of Java. Now these are the features which we are going to study now. Let us say one by one, very fastly and very precisely. We'll see all these Java features. The first one is Java language is compiled and interpreted. You know that there are certain languages which are compiled languages. For example, C and C++. You know, these two are compiled languages. Means you can use a compiler to compile the languages, whereas PHP and some other programs, they are actually interpreted. So there are compilers and interpreters. Okay, then here Java is both compiled and interpreted. So here we need to remember this word. Java is both compiled and an interpreted language. So here, if you see this diagram, you can understand that this is the original Java program. Every Java program, for every Java program, we give an extension .java. C language programs ends with an extension .c, right? C++ programs .c++. Likewise, every Java program has an extension .java. So program prog.java, this is the Java program. Now we give this program to a compiler. Now what this compiler does? Compiler generates a code which is called a bytecode. This is important in Java. Here the Java compiler generates bytecode, whereas it's not the case with C language. In C language, what happens is when you compile the program, directly the machine code will be generated, but here it is bytecode. Bytecode is also called as an intermediate code. So bytecode. Okay, then this bytecode is then given to Java VM, stands for virtual machine. Then here it is being interpreted, and then our computer executes the program. This is a two-step process. The first step is compiling. After compiling, what you get? You get a bytecode. Then take this bytecode and interpret it. Then you can get the output in your computer. So Java is both compiled and interpreted. Here we are using a compiler compiling. Then here this interpreter interprets the code. It's source code. Source code means program. So Java program is first compiled into a bytecode. That's what I told you here. The input of this compiler is Java program. What is the output of this compiler? It is the bytecode. Now here, if you can see that here bytecode program dot class. See here program dot Java. Every Java program, after compiling, what happens? A dot class file will be generated. This is bytecode. Then this code will be executed by using this interpreter. Java interpreter generates machine code from the bytecode. So Java interpreter, what is the input? Bytecode is the input. What is the output? Machine code. See, we say machine language, right? So here our program, Java program, will be converted to a machine language program uh, at the end of this, after interpreted by Java virtual machine. So Java is both compiled and interpreted. Platform independent and portable. Java is platform independent. What does it mean? Platform independent means that a program compiled on one machine can be executed on any machine. Here, the meaning of this word machine is, you can say that it's a computer. To understand, to understand simply, we can use this word computer. So, what does it mean? Platform independent means a program compiled on one computer can be executed on any computer. This is only possible with Java. In C language, you cannot do like this. In C language is not platform independent. C language is platform dependent. Here you can, I think this word is also new to you. Platform. You can say that it is, for your simplicity. Platform means, you can say it's an operating system for your simplicity. So Java programs are platform independent programs. Then just now I talked about the bytecode. Bytecode is a highly optimized code that is designed to be executed by the runtime system, which is called JVM. Just now we saw the virtual machine JVM. It's an interpreter for bytecode. Then the bytecode is machine independent. So we saw that Java program running is a, what is it? It's a two-step process. What is the first step? The first step is compiling by using a Java compiler, and the second step is interpreting, right? Now after the compilation, what happens? A dot class file will be generated. Then that dot class file, which is also called as a bytecode, is machine independent. Machine means computer independent. You can run the program in Windows operating system, a computer with Windows operating system, or a computer with Linux operating system, a computer with an Ubuntu operating system. See, this bytecode doesn't depend on which machine it is going to be run, so it is independent. Now, what is portability? Portability means Java programs can be moved from one computer to another computer anywhere and anytime. So this is what we mean. Platform independence means Java programs which are compiled on one machine can be executed on any machine. So Java programs can be moved from one computer to another computer. Almost these two are very similar, right? Then we see this image. Then here you can uh, say that, here it is Java code, Java program, test.java. Then it is given to a compiler. Now we are compiling the program. What is the output? Output is test.java. What is this test? It is the program name, test.java program name. Next, after compiling, bytecode will be generated. Just now I told you that bytecode is machine independent. Now this bytecode you can run on any computer. Here it is a computer with Windows. OS means operating system. Here Linux operating system, Solaris operating system. Each operating system has their own JVMs, Java Virtual Machine, an interpreter. Now this bytecode will be interpreted by this Windows JVM in the Windows operating system. This is what we call platform independent, right? And at the same time, portability. Portability means ability to carry to anywhere, right? We had, portable TVs. Long back we had portable TVs. Portable TV means the TV can be carried to any place. Similarly, this bytecode can be run on any computer, Windows and Linux and Solaris OS. But in C language is very different. C language is platform dependent, but Java is platform independent. Next, object oriented. We all know that Java is object oriented. In Java, everything is an object. Even the class, the main method also should be written inside a class. So all code and data must be written inside a class. So here in Java, what we do is we write everything inside a class. We start with like this class, some test class name, then we write some code, right? Even the main method. So there is something, right? In C language you write main, right? Main function. Here also in Java we have a main method, but with some arguments here. Yes, and another curly brace for the class test. In this way, what we do is we write everything inside a class. Inside a class, we write everything. All these things should be written inside a class. Java supports object-oriented programming features like encapsulation, abstraction, inheritance, polymorphism. All these things are supported by Java because it is object-oriented. Java is robust and secure. So the meaning of this word robust means it is strong. Now Java is strong. Java is strong, and Java is secure. It has strict compile time and runtime checking for data types. If you want to store the value in a particular data type, and if you are assigning that variable to some other variable, here in Java, it will strictly check the data type. Then there is one concept called exception handling in Java. Of course, it is there in C++ also. In Java, we will be studying exception handling, which will help us to eliminate the risk of crashing the system. We can simply, find out or catch the exceptions, and we can save the program from crashing. Now, Java also has a strong memory management system, and here in Java, we say something like GC, garbage collection. It will collect all the unused memory. So here in Java we have a good strong memory management system, so it is secure and at the same time it is strong, robust. Java is distributed. Java is distributed. Now, in Java, a program can be broken into many parts, and these parts can be stored on different computers. See, in a big project, what we do is we assign that project to a group of people. For example, let us say that 5 people they are doing one project. So what we can do is we can they those 5 people they can divide the big project into 5 parts, and in different places they may write the code, and finally they can combine their code. It is possible with Java. Java programmer sitting on one machine can access another program running on the other machine, and at the same time Java programs or programmers can access remote objects on the internet. So there is something called RMI in Java, which is called remote method invocation. Remote method invocation. So remote method means a function here. C language we have functions, right? In Java, those functions are called methods. Remote method, a method which is present somewhere, which is there in some other computer, which may be in some other country. So you can access that method from your computer. So Java is distributed. Java is simple, small, and familiar. Java looks like C++. You studied C++, right? In C++, the syntax of if condition, then while loop, for loop we have, right? All those syntaxes, very similar in Java. So if you are familiar with C++, very easy to learn Java. Then it is also very small, simple and small. Why? Because some features of C and C++ are removed from Java. For example, pointers. So in Java there are no pointers. Then preprocessor files are there in C language, right? We write with hash include stdio.h. Such things are not there in Java. There is one statement called goto statement, and there are certain things which are not in Java. Next, Java is multi-threaded and interactive. Java supports multi-threading. Multi-threading means multiple tasks can run at the same time. We have a separate chapter called multi-threading in Java. There is a separate chapter. There I will tell you what is a thread, how to create multiple threads, and what happens when we use multi-threading. So for your understanding, just think about this. In Java, multiple portions or multiple functions of the same program can be executed at the same time. Think about these three lines. I don't know whether you are able to understand this or not. In C language, let me compare this one with the C language. In C language, what happens when you call a function, then that function will be executed, right? Um, can you call two functions at the same time in C language? The answer is no, you cannot call two functions at the same time. But in Java, what happens is multiple functions or multiple methods of the same program can be executed at the same time. This is what important here. Multiple portions, sorry, multiple portions are executed at the same time. It is called multi-threading. Next, high performance. So the overall execution speed of a Java program is very impressive. So the Java program executes very fastly. Okay, then there is something called a JIT compiler, just-in-time compiler. What this compiler does? The compiler compiles the code on demand basis. That is, it compiles only that method which is being called. So if there are 10 methods in a program, if you are calling only one method, then that method will be compiled. So it is very fast when you see, when you look at the compilation like that on demand basis, then what happens is automatically your program will be executed very fastly. So high performance in Java. Then Java is dynamic and extensible. So Java supports dynamic linking of class libraries and class methods and objects. We'll be looking at this at later time. So dynamic means here at runtime, not at compile time. See, compile time is different from runtime, right? At runtime, you can link class libraries, and at the same time, Java supports some native methods which are written in C and C++. That's why it is called, extensible. C and C++ methods can be accessed here. In Java, we can create new classes from already existing classes. This is what we call inheritance, right? We are extending. So Java is extensible. Ease of development. Then the latest Java versions support different types of features in which they reduce the work of a programmer by transferring the work to the compiler. Some of the work which should be done by a programmer will be done by a compiler. So it reduces the development time. So it's ease of development. Scalability and performance. I gave here the definition of scalability. Scalability means the ability to overcome performance limits by adding some resources. Here what we can do is we can virtually add JVMs. JVM means Java virtual machine, so which really increases the performance of your Java program. Then some of the latest versions of Java have improved the startup time and reduced the memory usage and RAM usage. Memory usage means RAM usage. So if the RAM usage is reduced, then automatically your program gets executed very fastly. And finally, we conclude with comparing Java and C++ because C++ the extension, it is just an extension to C language, right? Object oriented extension to C language is called C++. Now Java doesn't support multiple inheritance. Yes, in C++ there is a multiple inheritance, but in Java we don't have multiple inheritance. Java doesn't support global variables, so they removed the concept of global variables. Everything you should write inside a class. Java doesn't support operator overloading, which is there in C++. Java doesn't have template classes. Again, in C++ we have template classes. Java doesn't use pointers. That's what I told you in the previous features. Java has replaced the destructor function, constructor and destructors, right? So Java replaced the destructor function with the finalize function, and there are no header files in Java. So Java is simple and at the same time very easy to learn. Thank you.